2048 is a challenging puzzle game that has gotten many people on the internet interested. Players slide blocks around, combining them to form large numbers until they eventually create the 2048 block. Every person has their own strategy for beating the game, and in this video, we're going to talk about a way to get computers to play the game for us, using something called the Minimax search algorithm. First, we'll talk about the more familiar domain of tic-tac-toe. It's X's turn to play, and there are three possible moves, which we've drawn here. From each of these three moves, the opponent has two possible moves, also drawn. Each of these boards represents a state of the game, and each move represents an edge connecting the states together. If we rearrange these drawings and limit ourselves only to the first and the last, it becomes more clear that we've really created a tree representing the space of possible states. We'll relabel each edge with the player who did the move to help keep things straight in the future. Now we need a minute to mention something called heuristic functions. Given a game state, or a tic-tac-toe board, the heuristic function tells us who has the advantage. Here, if x has 1, the function will return 1. If O has 1, the function will return -1. If there's a tie, the function returns 0, and all other possibilities will lie somewhere within that range. Now, we can go back to our state tree. At the bottom level, we'll label each state with the output of the heuristic function on that state. We want to evaluate the state of the game at our starting state, so we'll work our way up from the bottom. Remember, a more negative number means O is winning, so we'll set the value of each state at this level with the minimum value of the child states. At the next level up, X wants to choose the most positive outcome, so we set the value at this level as the maximum of all the child states. If X wants to win, he won't pick a move that leaves O with a clear path to victory. This is the Minimax algorithm, where we're able to take a game state, look ahead a few moves, and pick the move that gives us the best, worst case position. But how might we apply this algorithm to 2048? Tic-tac-toe has two opponents and 2048 just has the player. To see, we'll construct another state tree. We'll use a smaller board for illustration. The player has 4 moves, up, down, left, and right. After the player performs a move, the computer randomly inserts a 2 or 4 block somewhere into the board. So, from each state, there are 2 possible moves the computer could perform per open square. We draw these here, and we've constructed our tree with a randomized computer as our opponent. With the suitable heuristic function, we can now apply the Minimax algorithm to look ahead and pick the move that gives us the best position, even when everything else goes wrong. Unfortunately, this is where we're on our own. There is no universal heuristic. They must be tailor-made to the application. There has been much discussion in online communities about the best heuristic, and many of them evaluate the board based on the number of empty squares, the location of high-value blocks, and the nearness of similar blocks. Each has advantages, and perhaps a combination is best. Maybe you can even improve upon it by turning your own strategy into a heuristic. Or maybe you'll apply the Minimax algorithm to a different game or puzzle entirely. Either way, best of luck, and thanks for watching.